Hey everyone, in this video what we're going to do is we're going to solve the limit as x goes to 0 of a minus the nth root of a raised to n plus x divided by x, where a and n are natural numbers. Now we can't just let x go to 0 because then we would be dividing by 0. So we're going to solve this limit via two different methods. The first is a change of variable and second is L'Hopital's rule. So for method 1, let's begin by setting y raised to n to be equal to a raised to n plus x. This implies that x is equal to y raised to n minus a raised to n. Also, we need to incorporate this change of variable into the limit. So we have as x goes to 0, y goes to a. We get this from solving y raised to n is equal to a raised to n plus x by letting x be equal to 0, then taking the nth root of both sides of that equation. This allows us to rewrite our limit as the limit as y approaches a of a minus y divided by y raised to n minus a raised to n. Now we can factor a minus 1 out of the numerator and we have the limit as y goes to a of minus 1 multiplied by y minus a divided by y raised to n minus a raised to n. And we can use the following formula to rewrite the denominator as the following. Now substituting this expression into our limit for our denominator, we're left with the following limit, where we have a y minus a in the numerator and a y minus a in the denominator, which we can go ahead and cancel. And we're left with the limit as y goes to a of minus 1 divided by y raised to n minus 1 plus y raised to n minus 2 multiplied by a plus so on and so forth plus y multiplied by a raised to n minus 2 plus a raised to n minus 1. And if we just let y tend to a, we're left with the following. Now, a raised to n minus 2 multiplied by a raised to 1 can be rewritten as a raised to n minus 2 plus 1, which is equal to a raised to n minus 1. We have n of these. So we're left with a final answer of minus 1 divided by n multiplied by a raised to n minus 1, which is the final answer for method 1. Now on to method 2. If we let x tend to 0 in the numerator and the denominator, we have a limit of indeterminate form 0 over 0. And we can use L'Hopital's rule, which was stated for our specific problem, to solve this limit. Now to take the derivative of the numerator, we have to use the chain rule and the power rule. So we have 0 minus 1 divided by n multiplied by a raised to n plus x, all raised to 1 divided by n minus 1 multiplied by 1 divided by the derivative of the denominator, which is just 1. Simplifying, we have the limit as x goes to 0 of minus 1 divided by n multiplied by a raised to n plus x, all raised to 1 minus n divided by n, where all we've done to simplify the exponent is cross multiply. Now if we just let x tend to 0, we're left with minus 1 divided by n of a raised to n all raised to 1 minus n divided by n. A raised to n, all raised to 1 minus n divided by n, can be simplified by just multiplying the n by 1 minus n divided by n. So we have a raised to n multiplied by 1 minus n divided by n, and the n's cancel, so we're left with a raised to 1 minus n. And if we rewrite a raised to 1 minus n as 1 over a raised to n minus 1, we get the following final answer of minus 1 divided by n multiplied by a raised to n minus 1, which agrees with our answer from method 1. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe? If you have any questions or problems you'd like to see get solved, leave them in the comment section below and I'll try and get back to you as soon as possible. I hope you have a great day.